talking about. All right, give this one a shot. So omega again is rotational speed. Have a conversation. Notice that. Like, I think I see that. All right. Correct answer is D. Okay. So what this is looking at is how quickly you're doing one rotation. Okay. The equation is how big of an angle it does in a certain amount of time. And what this is talking about is this angle here, how quickly. Does that make sense? Like that's where that's coming. It's the rate at which this angle is changing. Okay. It might be helpful. It's like how fast it's spinning. They're both spinning the same rate. They're both revolving. Both make a revolution in the same amount of time. Okay. Have a conversation. Tell them why you think so. Sure. Make sure there's a reason. Green's my favorite color. Okay. Correct answer is B, green. Okay. So you got this equation. They have the same rotational speed, but green has a greater radius. This is kind of the math way. Conceptually, if you're running track, you prefer, if there's no staggered start, you prefer the outside or inside lane? Inside. Why? Less distance. Okay. Here, they're doing a race and they tie, but green is on the outside. In order to tie, running a greater distance, you have to go faster. Cool with that? Okay. Talk to your neighbor. Tell them why. Correct answer is A. Definition of acceleration is uh, that's the unit. What's the definition of acceleration? Yep, the rate at which velocity is changing. Okay, velocity communicates two things. What are those two things? Speed and direction. Okay, before you took physics, you knew that if you were speeding up, you were experiencing acceleration. You didn't need physics to tell you that. Okay, but then you learned that slowing down also constitutes acceleration. Okay, if you change the direction of velocity, but the speed remains the same, you are still changing your velocity. Okay, and this type of acceleration is known as centripetal acceleration. Okay, now if you are going in a circle, in a circular path, the direction of your velocity is always the way you're pointing. Okay, but if you're moving in a circle, the direction in which you're moving is constantly changing because you are always. Does everybody see this? Like, here's the way I'm moving. To move in a circle, I'm changing my direction. How quickly this goes towards the center of the circle, this is what centripetal acceleration captures or describes. Okay, the speed staying the same, but the direction of velocity is changing. How quickly you're changing your velocity towards the center of the circle, that's centripetal acceleration. Okay. The equation for centripetal acceleration is going to be those two. Now, last semester we talked about Newton's second law, the total force is equal to mass times acceleration. If we're moving at a constant speed, but moving in a circular path, special case, but we're going to find anytime you're moving it in this class, anytime you're moving in a circular path, you're going to be moving at a constant speed, just to keep things simple. Okay, so because you're changing your direction, you're still experiencing acceleration, and we have the same format as Newton's second law. It's just a special case for moving in a circular path. So centripetal force is equal to mass times centripetal acceleration. Okay. To dig a little deeper, force causes acceleration. Centripetal force causes centripetal acceleration. Just like here, the direction of the force is always the same direction as acceleration. The direction of centripetal force is towards the center of the circle. The direction of centripetal acceleration is also towards the center of the circle. Good with that? Tell your neighbor. Correct answer is C, towards the center of the circle. Good. Tell your neighbor. Tell them why you think so. Okay. Correct answer is B, green. All right. Now, this, looking at this is fuzzy. This route, that's definitive. Okay. They both had the same rotational speed, but the green had a greater radius. This, green's going faster, but it's also farther out. You might be able to argue, like, well, because it's squared, speed is squared, it has more influence. Green, but you see the fuzziness? Okay, this is like boom. Okay. All right, example problem. How fast can a, let me modify this. Fast. Better. All right, how fast can a 400 kilogram car take a non-banked circular entrance ramp that has a radius of curvature of 20 meters if the coefficient of static friction coefficient of static friction is 0.54 and the coefficient of kinetic friction is 0.43 between the tires and the road. There, that's better. Yeah, before it starts to skid. All right, so step one, probably identify what forces are acting on the car. So we are, oh, I should put this in here too. You're going at a constant speed. All right. So I heard friction. Which way is friction acting? Towards the center of the circle. All right, with that. Okay, is that going to be static or kinetic friction? Static. We don't want slipping or sliding or skidding. And because we want to look at it, how fast can we go right before it is maximum static friction. Okay. Gravity. Which way is gravity going? It's not going down. It's like going like in. Okay, so because of that, here's what I'm going to do. I'm going to draw my box like this. And modify it a little bit so you can see the perspective. This is the tires of the car. You're looking at the license plate. You okay with that? So here's your maximum static friction, gravity, and normal force. Right with that? Okay, just looking at a different perspective. Now, when you're dealing with circular motion, always, this is a big concept here, always make towards the center of the circle positive. Always. Make that the positive x direction. Okay? So make towards the center of the circle positive. Is the sum of the forces in the x direction equal to 0? Is the sum of the forces in the y direction equal to 0? Think about it. Have a conversation. Okay, have you seen? I'm assuming your online class probably didn't do this type of setup. Okay, so what I'm doing is anytime you have more than one dimension, we're going to separate it out into x and y. Okay. And we're looking at and we're asking ourselves, is the sum of the forces equal to 0 or not? And how you answer that, what you look at is you look at the motion. So if it's at rest and staying at rest, it is equal to 0.
Okay.
If it's moving at a constant velocity, it's still equal to 0 because that's what it wants to do.
Okay.
If it's experiencing acceleration, speeding up, slowing down, changing directions, it's not equal to 0.
Okay.
Does that make sense?
Yeah.
Okay, let's start easy. Sum of the force in the y direction equal to 0? Yes. Okay, it's not, the car's not getting air, it's not digging into the ground, it's at rest vertically. Okay, so we have our setup, normal force minus force of gravity equals 0. Okay, in the x direction, is the sum of the forces equal to 0? No, why not? It's experiencing acceleration in that direction. But I thought it was going at a constant speed. It sure is. But it's experiencing centripetal acceleration. See that? The subtlety there? If it's not equal to 0, it's equal to mass times acceleration. And so we have the only thing going on in the x direction is maximum static friction. Okay, so that's the difference between last semester's stuff and this unit. You're moving in a circle, so you have centripetal acceleration. Now, you've got centripetal acceleration is equal to speed squared over the radius. It's also equal to rotational speeds squared times the radius. More often than not, you're going to be using that one and dropping that in here. So you have maximum static friction is equal to mass times speed squared over the radius. Okay. Now, do we have mass? Yes. Speed. That's what we're looking for. Radius? Yes. Do we have maximum static friction? Is this 0.54? 0.54. This is the coefficient. That's this thing. Remember? Coefficient is 0.54. So anytime you're given the coefficient, are you kidding me? When you use this equation to find the maximum static friction. So that is the setup. I'm going to give you a couple minute head start. See if you come up with the answer. Go. Okay, so this is pretty involved. So, did you do anything like this last semester? Mm-hmm. Okay. Did you ever see this equation?
I think I've seen it like once.
Okay. So what you're doing is once we've set it up, then it just becomes a math problem. Mm-hmm. So this is the physics. This is how I describe the physics aspect. Now it's just like, all right, I've got this alphabet soup. How do I get? Okay, we're looking for this ultimately. Mm-hmm. So you need maximum static friction. Mm-hmm. We found maximum static, like we got an equation here for maximum static friction. So I got, in order to find this, I need a number for this and I need a number for that. Mm-hmm. So I got a number for this 0.54, but normal force, I don't have a number for that.
Okay.
Where could I find that? Where do you see normal force in your setup?
Oh, right here.
Good. Move this somewhere else, like over here or something.
This?
Yeah, like erase that and put it over here. You're gonna need some, like both of those.
Okay.
So this is where you find normal force.
Mm-hmm.
So do you have a number for force of gravity? Okay, what you have, you remember this equation. I'll do it over here.
Okay, yeah. Mm-hmm.
Okay, so you got the mass.
Mm-hmm.
This is 9.8.
Mm-hmm.
You can find force of gravity from here.
Okay.
And plug that in there. And find normal force.
Mm-hmm.
Use normal force here.
Mm-hmm. And then we already have that.
Yep.
So it's multiply it.
Yep. And then find the maximum static friction.
Okay.
So that you can stick it in here.
Okay.
Find the speed.
Okay.
Good?
Thank you.
Welcome. Okay. Here we go. Let's see how you did. So, I need normal force. Is this 9.8? No. Smiley, are you serious? Jerk. I do all this. Is this 400? No. That's a lame problem. So you have 400 kilograms times 9.8, and that's equal to 3,920 newtons. So you know that normal force is also equal to 3,920 newtons. So then you can take that, put that in there. So you have maximum static friction is equal to 0.54 times 3,920. Maximum static friction is equal to 2,117. Going over there. So we got 2,117 is equal to 400 equals speed squared over 20 meters. So I find that to be 20. Speed squared 2017. That is something. Divided by 20. 106. Take the square root. That is 10.3 meters per second. How do we do? 10.3 meters per second. Is that in the realm of possibilities? Is it ludicrous speed? No. 20 some miles an hour. Okay. So, if you're picture taking people, you could, that's, if that's helpful. Okay. A little involved, but hey, no trig. Okay. All right. So on the homework, if you're like, I don't know what to do, Here are the steps I just took you through. Okay, make towards the center of the circle positive. Towards the center of the circle, you're experiencing centripetal acceleration. So some of the forces are not equal to 0. So plug in mass times centripetal acceleration, and then you're going to substitute in for either for centripetal acceleration, speed squared over the radius, or rotational speed times the radius. The only thing that I did not incorporate in this example, if I give you the period, or I ask for the period, this is the only equation that has the period. Okay? So, yep. I will give you rotational speed in radians per second. Those in pre-cal, you've been exposed to radians. Those in algebra 2 have not. Radians, just okay. So you can measure distance in feet, or you can measure it in meters. Different units, same measurement. Angles can be measured in degrees. They could also be measured in radians. It's just a different way to describe, different unit to describe an angle measurement. Yep. All right. Give this one a shot. Bless you. Have a conversation.
Stop questioning Einstein.
Correct answer is B. Okay, so we're keeping the speed the same. We're increasing the radius. So in order to keep the speed the same, rotational speed needs to decrease. Good with that? Next question. Talk to your neighbor. Correct answer is correct answer is B. Mass is kept the same, speed's kept the same. The radius is increased. Inversely related, centripetal force decreases. Tell your neighbor. Tell them why you think so. Correct answer is A. Okay, if you triple the speed, we're squaring the 3 as well. Okay, so it becomes 9 times. Tell your neighbor. Tell them why you think so. Okay, what do you say? How much does it increase by? Doubles. You get a 4 on top because you square the double there, and you get a 2 down below, simplify that, it doubles the centripetal force. Good at that? Last question. Talk to your neighbor. Tell them why you think so. Correct answer is I hear A and B. A, B, show me. Correct answer is B. Okay, same mass. The radius is the same. As you increase the tension, the speed has to go up. The speed goes up, that stays the same. The speed goes up, tension, or sorry, not tension. The period has to go decrease. Okay, it takes less time to go 1 revolution. Good at that? Okay, you got a worksheet on Canvas due Monday. You know how to do it all.